look at 50 because this was probably our most missed problem on your quiz. You've been assessed for this type of problem 4 times, homework and on a homework check quiz. Most of you can label, so you'll give me the 36, you give me the 20, you give me the 34, sorry, here. And then you want to just say, oh, these opposite sides are congruent, so then y'all just say this is 34, which is wrong. That's what most of y'all wrote on a problem like this on your quiz. You have to know, or this is what y'all like to do. You like to draw this line like that. Nope. That's wrong too. That's not what you do. You have to create a rectangle and a right triangle. So you have to draw pretty much a line parallel to CD. And when you do that, it's going to be perpendicular because parallel lines are equal distance from apart each other, so it has to be perpendicular. So now that I have, basically, because I'm trying to find CR, or sorry, SD, then this is going to be X as well because opposite sides in a rectangle are congruent. I now have a triangle, and I have the leg, I have the other leg, which is X, and then I have the hypotenuse of that right triangle. You could find this missing leg by just doing, if this is 20, this would be 20 as well. Opposite sides in a rectangle are congruent, so this remaining is 16. At this point, when you're dealing with basically kind of like a pulley problem or trying to find the missing distance between the centers or whatever I ask you, you need to create a rectangle and a triangle. And then, yeah, it's 30. Then we're doing x squared plus 16 squared equals 34 squared. Pythagorean theorem. It's 30. It's 30. No, I'm going backwards. I'm going up. Okay. All right, so, all right, any questions on, well, 48, you have to work backwards on 48. We did this like 11.3. We did this like, it's been a while. Yeah. All right, so, basically, you can take the arc length, it's equal to 2 pi r times the angle divided by 360. That's what we're trying to find is the angle. But I know the radius is 10, so I can go ahead and plug that in, which gives me 8 pi is equal to 20 pi times x over 360. Well, basically, because I know I'm trying to solve for x, I need to get rid of divide by 20 pi. The pi's will cancel out, and I know that this ratio, which is, I believe, 2/5, is equal to x over 360. So you can cross multiply to solve for the missing angle. So you can cross multiply, solve for x. It's 144. Okay. All right. Next page. So basically, a page at a time. There's some stuff I read on here. If you haven't taken the time to use the flashcards on your metal, really a lot of this test is being able to read the figure, read the given information, identify what property or theorem to use. So I'm not sure if you got to this page, but I'm not going to do like each problem. I'm just going to ask you, do you have a question about a type of problem? And then go over it, Ryan. Yeah. Huh? This problem, 47. Okay, so they tell me AB is congruent to DC. That means that the arc AB is congruent to the arc DC. If the chords are congruent, then its corresponding intercepted arc is congruent as well. And then it tells me that the central angle CQD is 120. And when it tells me the measure of the arc BC is 30. So this would be 120 is the arc here, 120 is the arc there as well. Yep. Okay. So DC, we already have AD. We're just using, yeah, the remaining of the circle. 120, 120, 30 minus 360. Yeah, you're right. And then AB, the measure of arc AB, we already know it's the same as DC, which was 120. And then they're asking for the angle CQD, this angle here, it would be 30. Because this is a radius and this is a radius. You have an isosceles triangle, 30 and 30. Plus 120 is 180. Okay? So there's multiple properties within central angle. You have central angle. You have congruent chords and arcs. You have isosceles triangle. You also have basically your test is broken down to, do you know the angle relationships and do you know the segment length relationships? So there's like pretty much 4 different rules for each one. All right. 44. All right. There's 2 ways to solve this. So first of all, you just got to see, this is not asking about angles. It's talking about segment length. So you have to know a segment length rule. Okay, all right. So you could use tangent secant. But the problem with that, picking that, is that do you have a secant right now? No. You have a tangent. Yes, this is a tangent. But Q to T is not a secant. You would have to add the radius at that point to create the secant. Okay, by doing that, that means that's 5 as well. And now this would be your secant. There is an easier way to this problem. There's another property you could use. The tangent is always perpendicular to the radius. All right, so I'm going to do that for you real quick because this is faster for me. If I draw the radius, sorry, I got Pythagorean theorem because I already know the radius is Q to S is 5, so that's 5. That means this part is your C. You had a problem like this on your quiz, and some of you tried to do tan secant, and you didn't add the segment, and then some of you tried to do the expression x plus 5. But you could do that, but that means you have to square a binomial. And so this was easier because I could see that the legs are 5 and 12, and I can get my hypotenuse. And if I know my hypotenuse, then I know I can figure out the remaining segment on the outside. Josh? Because that's a property of a tangent. A tangent is always perpendicular to a radius. All right. So let's go to the next page. I'm assuming 42, that's the one that most people have been asking about. So this goes back to what that property I just said. X is your tangent. A tangent is always what? Perpendicular to the radius. So I'm not going to put the box there. You're supposed to know that property. You're going to draw the box. You're going to apply that property. The tangent is always perpendicular to the radius. And once I do that, we now should see we have a right triangle and Pythagorean theorem. Yes? Well, I don't know what side you're referring to. If the a squared is your hypotenuse, then yes. No. No, order of operations. Exponents before subtraction. You have to square them. Always squaring. Exponent is PEMDAS. I mean, exponents always come first. Okay? So there's no subtracting before that. Okay? Okay, so, all right. Pythagorean theorem would be a squared plus b squared equals c squared. So you got to substitute the parts into Pythagorean theorem. A here, B are the legs, C is the hypotenuse. So what are my parts? 16 could be a squared. That is correct. That is a leg. Plus x squared. That is also a leg. No. X plus 8 squared. The hypotenuse is the longest side, is the side opposite the right angle. That means we have to add those two parts together to get the C. Now, some of you did this approach on the quiz, which was fine. You still could have got to the right answer. But then when we had to do this part, the algebra, that's when you lost it. You're going to be expected to know how to do the algebra. Whenever you square a binomial, some of you know a shortcut. But basically, this is saying I have two factors of this expression, x plus 8. So that's just saying x plus 8 times x plus 8 using FOIL method. There's a shortcut. Anyone know the shortcut? Square the first one, first term. Product is 8x multiplied by 2, 16x, excuse me. You square the last term, 64. So we got 256 plus x squared, and the x squareds end up canceling each other out. So you get a linear equation, which you should be able to solve. Because you multiply the two terms, you get the product of the two terms, and you double it. Josh? 41. With theorem, Conehead. Conehead tells me what? That they're going to be congruent. Yep. So we just got 3y equals 5y minus 28. Are we okay on that? There's no such thing as tangent. We don't have a rule that's tangent. We have tangent secant. Yeah. Okay, so you're definitely going to have a quadrilateral inscribed in a circle. Do we need to address this section, 39? I don't think so. All right. Probably 38. And what I did was I said, look at angle 1, because I want you to find angle 1 and angle 2. So I look at angle 1. What arc goes with angle 1? Okay, then I look at angle 2. What arc goes with angle 2? Okay, so since they intercept the same arc, they're congruent. So you should start off that angle 1 is equal to angle 2. They intercept the same arc. So then you can solve for x, right? And then plug it in. Angle 3 is also equal to angle 4. They intercept the same arc. All right. Now, this was probably one of the most missed previously, because you have to use your chord property, which was our chord theorem number 1. Not chord. Congruent chords. So basically, we know that the pentagon is inscribed in the circle. All sides are congruent. I want you to find the measure of each angle or each arc. If all sides are congruent, like that, then the intercepted arc is also going to be congruent. So this should be real simple. Huh? Yeah, there's a simpler way than that, Josh. 72. Thank you. 360 divided by 5. Yes, 72. I don't need to make an equation. Just using the relationship. All right, next page. All 5 of them. Oh, you talking about like... Where am I? Well, not all of them. Just 35 and 36, not 37. 37 is BIG. It's the inscribed angle. No. Yes, it is. BIG. It's intercepted arc. BIG is an inscribed angle. It is half the intercepted arc. The intercepted arc would be BODG. That arc right there. Okay. All right. Sorry. Back to where we were. Yeah. Yes, that's right. All right. Do we have questions on this page? You should have got to this page. What number? 31. Name the intercepted arc for GTR. So I go from G to T to R. That's the inscribed angle. What is the intercepted arc? I'll take two answers. Huh? Okay, so right there, G to R, or R to G. Yes. G to R. It goes over who? Okay, I understand that. But for it to be major, what must it have? A measurement of. Yeah, no. If it's a major arc, it has a measurement of what? Greater than 180, less than 360. Yes. For it to be major, it has to be greater than 180, but less than 360. Okay? Yes. Yeah, the points, yes, you're right. Yeah, uh-huh. Or, like, some people might go to R to G. It's the same thing. All right. Yes. No. It's not a major. Yes, 3 letters. Yeah. Okay. Oops. All right. I had people ask about 30. Don't make this more difficult than it needs to be. Yeah, they're supplementary. Okay. Yeah, 180 minus 75. Okay. Oh, yeah. It's not trick. The easy ones are the trick questions? Because they're so easy? Okay. 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 Remember the tangent is perpendicular to a radius. Okay. So, remember that. I know they haven't drawn this, but that is 90 degrees right there. But you should be able to find this angle. Yes, because they're supplementary. So, this is a central angle. The measure of that central angle would be what? Huh? It's 54. Okay, so that means the arc RT is also 54 because it's a central angle. Does that make sense? Okay. Huh? So yeah, so we got 54, yes, and 126. So they're asking you to draw the angle T to R to S. See what I did there? T to R to S. So you have to draw that chord TR. Okay? No, not T to R to S, no. Yes. 63. BRS, yes, is 90. Alright, I think we're okay with these. Okay. You know inscribed angle and intercepted arc? No, that's not an inscribed angle. On the circle, it's inscribed. Central is inside. Interior is inside. Central center. Interior is inside the angle. A circle. So if this is angle one is really CAD, right? What arc is inside of that angle? So there we're done. Two intercepts also CD. So angle one is equal to angle two. Yes, you're right. Okay. Alright. Alright, this section, this page. Oh, there's an error, excuse me. Error. That should be 5x.
I feel something wrong with this. I could not figure it out.
Sorry, please correct it. 20. Fix 20. Fix 20. Fix 20. Fix 20.
Now I have to minus 5, what, x minus 6 plus 1.
X minus 6.
X equals 5, 1.
Oh, wait, you just said x minus 6 plus 1.
I mean 6.
Yeah, we just said it. Okay, alright, so, do we have questions on this page? 19. You have to draw the picture, I believe. They didn't give you a picture. Yes, it is Pythagorean. So you have a circle. Yeah, it is the same as 18. You draw the chord. The chord is 48. It is 10 centimeters from the center. So you draw that. That's 10. And from the distance from the center is always perpendicular. So you're trying to find the radius.
49.
What happens to the chord? Yeah, it gets bisected. So it's 24. Alright, so we got a right triangle. You should get 26 for the radius. 18 is like 19. Oh, 15, that's a good question. So, I'm hoping y'all got 4 here, right? Okay. There, and 4 here, right. And so they want this arc. That goes with that central angle. Y'all agree? Okay, so we're trying to find the measure of that angle. All right, so I'm looking at opposite and adjacent. So I'm going to do 10 inverse 4 over 3. On 15, you have to use trig. I think there's one. All right, and then the first page. Anything off the first page? Is it you just want the answer? Okay, do we know that this is the diameter? Okay, anything else you know? Y'all know that that's right? Right, because the diameter cuts the circle in half. And whenever you have a semicircle, the inscribed angle is always 90. Okay, so what's the diameter? No, you shouldn't have to use Pythagorean. What is the diameter? No, not 6 root 2. The diameter is 3 root 2. You said 6 root 2.
I have it on paper.
Okay. Because the two legs are congruent. A 45 is an isosceles. Alright, so circumference is just pi times the diameter. So 3 root t times pi. You said 6 root 2. I didn't hear 3 root 2. I didn't hear the 3. Okay.
You know what I'm saying.